Lesson 1. The equations and graphs of lines. So first of all, we're going to look at the equation of a line. The equation of a line is usually in the form y equals mx plus c. This is slightly different than what we had before, y equals a plus bx, but the values are similar. First of all, we have our gradient, m. This is analogous to b in our original example, or what we did in the data management unit. M is calculated using this nice little formula, rise over run, or y2 minus y1 over x2 minus x1. And we'll go into a little bit more detail about what that means shortly. And C is the y-intercept. So it's where the graph crosses the y-axis. If m is positive, the graph is increasing from left to right. So it looks like this example here. But if m is negative, the graph is going to be decreasing or going down from left to right. So m is negative and m is positive. Work through the first example and then come back once you're finished. You can check out the video if you'd like. Sketching a line in the form y equals mx plus c. This is the most common way, for the most part, of seeing lines. Let's look at how we graph them. First of all, we'll plot the y-intercept, which is the point 0, c. Again, that's our y-intercept. We're then going to write the gradient as a fraction, and I'll show you how to do that in a moment. And we need to do that because to find another point on the line, we start from our y-intercept, and we're going to move. We're going to move either up or down, and then across. So in our example, if m is 2, I'm going to write that as a fraction 2 over 1, which is any number divided by 1 just gives itself. So here m is positive, so we're moving up 2 units because the rise is 2. And then we're moving right 1 unit because the run is 1, and we always move to the right. We're going to plot that new point. So I've got my original point, and then up 2 over 1, I've got a second point. Connect them with a line, put arrows on the end, and label it with the equation. That's how we plot a line in that form. You can try these examples on your own. You can check the video out if you'd like. Sometimes a line is in a different form. ax plus by equals c. We'll sketch this in a different way. We'll sketch it using 2 key points, the x and y intercepts. First, let's find our x-intercept. We know that the x-intercept is where the graph crosses the x-axis, and at that point, y is 0. So we'll substitute in 0 for y into our equation here. We'll let y equal 0, and we'll solve for x by rearranging the equation or using solve on the CAS. Then we're going to do the same for the y-intercept. With the y-intercept, we know that x must be 0. So we'll let x equal 0, again, in our original equation, and solve for y, using the CAS or by hand. Once we've plotted those 2 points, our x-intercept and our y-intercept, connect them, add arrows, and label, just as we've done before. Check out the example, come back when you're finished. Sometimes, though, we're only concerned about part of a line. We don't need to see the whole thing. In this case, you'll be given 2 x values, and will be asked for the graph between these 2 values. So say I only want a section of line between x is negative 2 and x is 4. I only want that part. So to do that, you're going to substitute in those given x values, whatever they might be. I'll call those your because that's what we're looking for here. We're looking for the values of those 2 points at the end of the line segment. So substitute x and solve for y.